let's have a look at 4/10. 4/10 we know from the previous explanation will work and will be a decimal, but it is not a decimal yet, as shown in red at the top. Decimals are a system of recording without using denominators. So the digits can't have a line and a number at the bottom telling us what type of fraction it is. That's the whole point of decimals, is that we know that they're tenths, hundredths, thousandths, and so on. So we can write them as a shortcut using a decimal point, which looks like a full stop, and we put these digits in certain places so that we know what fraction we're talking about. So 4/10 in red has a denominator of 10. It is shown as a common fraction, not a decimal. Now looking at the bottom of the screen, we can see in navy blue, I've written tens, ones, then I've put a decimal point or a decimal dot, then tenths, hundredths, thousandths. These words represent the place value of the digits that would sit in those positions. So we're pretty familiar at this stage with tens and ones. If we have a 2-digit number, we know the first digit is much larger than the second digit, that the first digit would represent how many tens there were, and that the second digit is smaller and it represents only ones. The same type of idea is continuing in what we call a diminishing scale, which means it's getting smaller and smaller after the decimal point. So tenths is a 1 cut up into 10 pieces. So they're still pretty big fraction pieces. And then hundredths, the next digit along, is actually much smaller. It's each of those tenths cut up into another 10 pieces, resulting in them being 100 pieces of the original shape. And then thousandths is everything cut up by another factor of 10. So now we've got a shape cut up into thousands of pieces, 1,000 pieces. So looking at 4/10, we would quite simply put the 4 in the tenths position in that number. Then we need to make sure we have our decimal placing, and that will allow us to know, based on where the decimal point is, that we are now talking about tenths, because the digit directly to the right of a decimal place is the tenths column or the tenths position. Then we could put in zeros. So we could say we've got 0 tens because we don't have a very big number. We've only got 4/10. We don't have any ones. We also don't have any hundredths or thousandths. So we can put zeros in to show this. We could actually put zeros going on forever to the right and forever to the left, because we don't have any hundreds or thousands or 10,000s or hundreds of thousands or millions, and we don't have any 10,000ths or 100,000ths or millionths and so on. So they're not very much necessary. We don't need to put those zeros there, because if we remove them, we can still see we have 4/10. Similar, if we remove the 0 at the front in the tens column, we can still see from the 0.4 that we have 0 ones and 4/10. Now if we remove the 0 from the ones column or the ones position, we can see we have 0.4, which is still 4/10. The problem with doing this, however, is this can lead to errors. We might we mistakenly think that this is the number 4 and that there's just a dot or a smudge on the page. So if we don't have any tens or ones or any whole numbers larger than a fraction, we will make sure that we put a 0 in the ones column, just so that it helps us recognize that that decimal point is meant to be there and it's not just an accidental dot or smudge. So of course, now as it's shown as 0.4, it is a decimal, and it can also be read more properly as 4/10. So we could read the top number with the denominator, 4 and a line and the 10 underneath, as 4/10, but we can also read the decimal if we're wanting to read it clearly to ourselves as 4/10, rather than getting lost and confused in the shortcut way of saying 0.4. Moving on to another example, let's look at the number 21. This is also a number that can be classed as a decimal. It's a whole number, so we don't think of it as a decimal, and the way that I have it recorded says it's not a decimal yet, but let's think about this for a moment. Perhaps it is. To record 21, we would say it's got a 1 in the ones column and a 2 in the tens column. 21 is made up of 2 tens and 1 1. It does not have any tenths, hundredths or thousandths, and we could put zeros for all the fraction decimal placings beyond the decimal point. So we don't need to actually include those. So 21 is just 21, and there's a decimal place assumed to be there. But in fact, we don't need to include the decimal, so I've just rubbed it out. So yes, 21 is a decimal, and there is always, in all whole numbers, assumed that the decimal point is sitting there. Even way back when we're first starting school and learning to count, all the numbers that we're writing down, it's assumed that there is a decimal place there. However, because there are no decimal fractions that are within that whole number, we don't include it. Let's look at a more specific example back on track to what we're going to encounter when we use decimal points with the example of 300ths. So as stated previously, this will work as a decimal, but it's not a decimal if it's represented as a common fraction with a denominator of 100. So we would put our 300ths in the hundredths placing, as shown added in down the bottom. That means we still don't have any tens and we don't have any ones. We are looking at something that is smaller than 1. We still need our decimal placing, but we need the 0 in the tenths column because we don't have any tenths. So this 0 is really important. And we can see if this 0 was missing, then the 3 would be next to the decimal point and so would be in the tenths column and would be misread as 3/10. So that 0 lets us know that the 3 represents hundredths. And then, of course, we've got no thousandths, so we could put a 0 there if we pleased. However, we don't need it because we still know it's 300ths with it removed. Similarly, we don't need the 0 for the tens because without it, we can still see we have 0 ones, and we know that that means we don't have any tens, hundreds, or anything larger as well. We still keep this 0 out the front though, again for the same reasons described earlier, so that we can notice and recognise where the decimal point is and know that it's intended to show us a decimal. So now we have 300ths represented as a decimal, and it would be written as 0.03, but I would still encourage students to read it as 300ths to ensure the understanding is becoming strengthened. Next, let's look at a mixed number, 37 and 5 thousandths. Now we could record the 37 as 3 tens and 7 ones, and then we have a decimal placing to show that that is the end of our whole numbers. Now we're looking at the decimal fractions after the decimal placing, and quite clearly we have 0 tenths and we have 0 hundredths. We only have 5 thousandths. So we'd record this one as 37.005. And again, I'd encourage students to read it as 37 and 5 thousandths, just to avoid confusion when they're dealing with what the decimal actually shows.